Alright, so I didn't realize that there was another page to this. I probably should have, since I'm the one who wrote it. But anyways, this will be the fundamental trig identities part 2. And so we'll go ahead and work through these. Like I've been saying before, please press the pause button and try and attempt these on your own before seeing the solution. So let's go ahead and work this one. So first thing we do is we're going to start on the left-hand side. And then when we work on the left-hand side, we're going to go ahead and not change these guys over to sine and cosine just yet, since tan and cotangent are multiplicative reciprocals. So we have tan squared theta plus 1. Since tan squared theta plus cotan squared is 1. Alright, so that's it. That's our left-hand side. Let's go ahead and convert this into sine and cosine. Like so. And now let's go ahead and get a common denominator going. We'll go ahead and just place that right there. So we want a cosine squared theta over cosine squared theta. Now we combine those. We'll go ahead and switch the order so that we get cosine squared theta plus sine squared theta, so it's in our more familiar form. And so you note that cosine squared plus sine squared, well, that's going to equal simply 1 over cosine squared. And now we can use the Pythagorean identity on cosine squared and replace it with 1 over 1 minus sine squared theta. And if you're having trouble saying that, you know that's simply cosine squared theta plus sine squared theta equals 1. And if you note, when you move either one of these over, you'll simply get 1 minus. Alright, and so that's it. Left-hand side is the same as the right-hand side. Good. Let's move on to the next. So we notice that on the right-hand side we have conjugates at work, so we'll go ahead and multiply those through first. 1 minus cosine squared theta. Recall this one of the algebraic identities we looked at in the beginning. And then on the left-hand side, we're going to convert this into sine and cosine. So up on the top we have, and our tan theta, we're going to put that in there. So that is sine squared theta over cosine squared theta. And then here in the bottom we've got secant squared. And secant squared is 1 divided by cosine squared theta. And so this can basically be rewritten as sine squared theta times 1 over cosine squared, all divided by 1 times 1 over cosine squared theta. So you can clearly see these guys cancel out. All we're left with is sine squared. That doesn't quite look like what we have up here on the right hand side, but we simply apply the Pythagorean identity. 1 minus cosine squared is the same thing as sine squared theta, which is what we have here, and so the left hand side is equal to the right hand side. So you can kind of see how we worked both sides towards the middle. Alright, next one. We've got tan theta minus cotangent theta on the left, all over sine cosine. So let's see. let's go ahead and just make one quick observation on the right hand side. It might help us, it might not, but we're going to go ahead and write it anyways. We can see that these are conjugates here, or can be broken up into conjugates pretty easily. So we have secant theta plus cosecant theta multiplied by secant theta minus cosecant theta. And again, that might help us, that might not help us. A lot of this is kind of like just trying to figure out your way through a maze. A little backtracking here and there, but we might use that, we might not. We'll see what happens. So let's look at the left-hand side. And let's go ahead and break it up into sines and cosines. So tangent, well, that's going to simply be sine theta over cosine theta. And then cotangent is the opposite. Cosine theta over sine theta. And then here we have this right here. Okay, so let's go ahead and get some common denominators going. Go ahead and so we want this guy to have cosine theta over cosine theta. And then here we want this guy to have sine theta over sine theta. And so we'll end up with, this will be sine squared theta, and then minus a cosine squared theta all over cosine theta sine theta, and then again divided by cosine theta sine theta. Now these do not cancel out, because they are slightly different expressions, but I'm talking about these guys here. They do not cancel out. Also note, this is not the Pythagorean identity either. It is and we could certainly use the double angle identity, but that will not help us in this case, as there are no double angles at play here. For those of you who are looking ahead anyways. Alright, so what we're going to do is we're going to multiply top and bottom of the bigger fraction by sine theta over times cosine theta. So again, sine theta, cosine theta. And note that up in the top expression, this guy here cancels with this guy here. And so now we're left on the left-hand side. Let's go bring it all the way back here. With sine squared theta minus cosine squared theta, all divided by sine squared theta times cosine squared theta. Right, because we just multiplied these two guys here. Now let's go ahead and distribute to both of them. So the first one, we're going to have 1 over cosine squared theta. And then the other one, cosine squareds will cancel out. And so we're going to be left with 1 over sine squared theta, which is the same thing as secant squared theta minus cosecant squared theta. And that is our original right-hand side. Alright, so note, even though we wrote this out, we ended up not using it. That was just something that might have been able to use, we might not have. If you notice something real quick off the bat, sometimes it's good to take a note of it, just in case it becomes useful later on. Alright, next one. So next one, we notice that we have this quantity here and this quantity here. Those quantities are conjugates of each other. So that's an interesting thing to note. So let's go ahead, and this time we're going to start off with the right-hand side. And we're going to multiply top and bottom by the conjugate here. Like that. And so we multiply on the top, so we've got cosecant theta times secant theta minus tangent theta. And note that I'm leaving this in the blue. And so we're going to multiply this guy by, or down at the bottom, it was multiplied by the conjugate. So this guy's got to be secant squared theta minus tangent squared theta. Alright, so lifted it in blue so to call attention to it. Note that this right here, oh, and I'm sorry, this should have been a plus there and a plus there. And so note that that guy in blue, yellow right there, same as this guy here. So we already got a part of the left-hand side already at work. So here's what we're going to do. We're going to leave it alone, and we're going to work with everything else to see what happens. So now when we look at things, we can see that what is left, this guy here, well, correlates with this. So basically we need everything I circled in green to equal to 1 over sine theta for this whole thing to work. So let's go ahead and convert everything into sine and cosine to see what happens. So up in the top we've got 1 over sine of theta. And in the bottom we've got 1 over cosine squared theta, and then minus sine squared theta over cosine squared theta. Alright, just so you can see everything. That goes to that. This guy goes with this guy. And this guy goes with this guy. Alright. So this is this guy on the top. We're just going to bring that sign to the bottom there. And this guy in green and the guy in blue, we note they have a common denominator. So cosine squared theta over 1 minus sine squared theta. And, I think I forgot to write this in. Sorry, guys. There we are. Now note, we got a sine theta here, which is what we're looking for, sine theta in the bottom. So let's go ahead and start writing this in blue now. As we work through everything. So here we've got 1 divided by 1 minus sine squared. But note that 1 minus sine squared is the same thing as cosine squared, via the Pythagorean identity. And then over here we've got secant theta plus tan theta over sine theta. Note that is precisely what we're looking for. And then on to over here, cosine squared over cosine squared obviously is just 1. So this whole thing is just 1. Note that we are now equal to the left-hand side. Alright. So in this one, note that we did not start from the left-hand side, we started from the right-hand side. There is no rule that says you must start from the left-hand side. So when doing these, you obviously have to show that the right-hand side does equal the left-hand side, but how you show that is does not matter which way you start. Alright, so this problem here, is very similar to the problem we just did. Please at this time press pause and try to work through it on your own if you're not doing so already. Okay, so go ahead. We come here. We notice that we have these two guys here that are conjugates. So let's go ahead and start with the left-hand side this time. You could just as easily start with the right-hand side as well. But if you start with the left-hand side, we have cosine theta over 1 minus sine theta. And you're going to multiply this by the conjugate. Which is going to leave you with cosine theta over 1 minus sine squared theta. And then we've got this 1 plus sine theta hanging out, because we see that we got a 1 plus sine theta here, 1 plus sine theta here. So we're going to leave that guy alone. This guy right here, we leave alone. Alright, 1 minus sine squared. That's simply the Pythagorean identity, that is cosine squared. So this equals cosine theta over cosine squared theta. And then multiplied by 1 plus sine theta. Alright, so clearly cosine divided by cosine squared is 1 over cosine theta. And so we end up with 1 plus sine theta over cosine theta. And that is the same thing as the right-hand side. There we are. Alright, so this one, bit of a challenge one. So do see if you can work it out on your own. See how far you can get anyways. See if you can get all the way through. So a quick thing that we see on the right hand side is this quantity right here. Well, that quantity is one of the algebraic identities that we looked at the beginning of the handout. And so this is 1 plus sine theta quantity squared. If you have trouble seeing this, look at the very front of the handout with the x and y algebraic identities. Alright, all divided by cosine squared theta. Alright, so we're going to leave that one alone. Let's go ahead and switch over to the left-hand side. Right-hand side is all in terms of sine and cosine, so let's get the left-hand side the same. So secant, that's 1 over cosine theta. Tan is sine over cosine. Okay. very good. And just to make sure everyone sees everything, let's go ahead and do our highlights. Alright, so fortunately everything that we're adding and subtracting already has common denominators, so we can set this up in the top as 1 plus sine theta divided by cosine theta. And then in the bottom we have 1 minus sine theta divided by cosine theta. Alright, good. So now let's go ahead and pull these 1 over cosines out. We have 1 plus sine theta divided by 1 minus sine theta. And up in the top, we have 1 over cosine theta. And then over here, 1 over cosine theta. So it should be pretty clear that this cancels with this. And so now we're going to multiply across by the conjugate of 1 minus sine theta, which is 1 plus sine theta over 1 plus sine theta. And so when you do this, you multiply across. And on the top we get 1 plus sine squared theta I meant to say 1 plus sine theta quantity squared, sorry. And in the bottom we've got 1 minus sine squared theta. And 1 minus sine squared theta is the same thing as cosine squared theta, which is what we're looking for. And in the bottom we have 1 plus sine theta. In the top we have 1 plus sine theta quantity squared. And so we note that this all matches with this quantity here. Left hand side equals the right hand side. Okay, that's it. That is the entirety of the handout this time. So have a good day, and until next time, make sure that you keep practicing these. And I know I said it at the end of the last video, I'm going to say it again. Look for similar problems in the textbook. Please do not rely simply on the homework to prepare you for this. Go through the homework and just find problems that are similar to what you saw in this handout, and just practice with this one. It really is a valuable skill to have. So please do yourself a big favor and get a lot of practice in with these. Good day.